When sending OBM model to RM, some information needs to be provided, such as the standard code and the material list, some general settings, the superstructure and infrastructure number of elements and restraint conditions, and the RM bridge materials. So for steel cross-section or steel composite cross-sections, the definition of slender cross-section parts is required to consider the local buckling phenomena due to the compression forces. In RM bridge, slender parts are defined as reference sets of the cross-section. These reference sets have to be the type of steel slender part, and the subtype can be web, flange, box, or rib. So after OBM model is sent to RM bridge, it's necessary to go to RM modeler and complete the necessary information in the deck cross-section. We have already placed in RM catalog one complete deck cross-section that we can insert into the project. So here what we have done was to define the slender parts of the I-steel girders for webs, top and bottom flanges. Slender parts are lines between 2 points of the cross-section with the thickness as an additional parameter. The characteristic slenderness value is used for cross-section type classification, considering the different rules in each standard code. So in HSTO, it corresponds to the lambda value. So one important information is to check if the parts that belongs to steel are settled as a high-rolled profile. So now we go to main girders and replace the deck cross-section by the new one. And now we can send the model again to analyzer for calculation. So for the design check capacity of steel or steel composite cross-sections, so UTRES is the scheduled action that needs to be used. So UTRES calculates the design resistances independently of the actual stressing state. It calculates the standard plastic resistance, elastic resistance, the reduced resistance due to the local buckling, and the reduced resistance due to the flexural and torsional flexural behaviors. The res check compares the calculated design resistance with the relevant ultimate load state by using the appropriate interaction formulas. So here in this diagram for the bending moment, as you can see, we have the results for the 5 composite beams. And we can see the ultimate bending moment and the design capacity moment too. So at this stage, we are going to have the schedule actions for the calculations. So here we're going to read one TCL file that called schedule and add it to the project. So in Analyzer Schedule Loads definition, the user can see all the information introduced in the model, such as the combination table, the load management table, and the load case definition, where we can look at the load cases that have been defined. In traffic lanes, it's possible to see the preview of the selected lane after run. And in load trains, the traffic loads definition. So here in this example, we have used the HL93 load trains. In stages, schedule actions are introduced. All the actions or commands to be run. For the design check capacity, UTRES is the action that would be used for steel and steel composite design calculation. So now we can recalculate analyzer and do the run. So during the run, it's possible to produce plot diagrams. So in this example, at the top is presented the factory force results for longitudinal bending moment at left and the shear force at right. And at the bottom, diagrams for the design check capacity for bending and shear. Rating factors calculation is done with the RateF schedule action. So it's possible to obtain plot diagrams with the rating factors results. So as we can see here in the diagram that is presented at right. So let's see in the next video how to do it. So at the top table, we are going to create one stage for the RateF calculation. At the bottom table, we introduce the commands or schedule actions to be run, in this case, RateF. So in RateF, it's necessary to introduce the permanent and live load results. So they can be factoried results if desired. The capacity results previously calculated by the program, the combination factors, result name, and the output file name. So we added two RMSets diagrams for plotting the RateF results. So one for the bending moment and another for the shear results. And we can now run the model. So in this running, two new diagrams will be displayed. So at left, the rating factors for the bending moment, and at right for the shear. These rating factors are on composite elements. So we can also open the Excel output file and look in more detail at the results obtained. And so if we go to the moment MZ spreadsheet, the lower rating factor obtained was around 1.5 on element 314, that is a composite element over the central pier. So some questions from our users. Is the RateF improved for imperial units? So yes, so since OBD Connect Edition 2021 Release 2 and RM 1113, the RateF was improved for imperial units too. So as we saw, RateF evaluates the load rating factor according as to code. So this action is currently only applicable for stores, and it requires that the capacity design was previously calculated by the program. Can RateF be applicable to cross members? Yes, RateF can be used in rating evaluation of cross members too. So the user needs to prepare the model for it, as loads need to be applied on cross members and also for the capacity design. Cross members can be defined with steel cross section or composite steel cross sections. How do I see rating factors results? So as we saw, the user can obtain rating factor results by plot diagrams, by text files, and by Excel spreadsheet files. Rating factor plot diagrams are generated through RMSets definition, and output text files and Excel spreadsheets are generated automatically with the RateF, or they can be generated through RMSets as well.
So we recently moved from a 2D LARS program to a 3D version of LARS. We call it as LARS Bridge, wherein the users can model and perform load rating analysis on existing and planned bridges in a streamlined process. It's an exclusive program for rating of concrete and steel bridges. I would request the users to download from Bentley software download website and try to use it. The program can handle AASHTO LRFT code, LFT code, and allowable stress design.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.